Hello again. In our previous video, we looked at the reduction of carboxylic acid derivatives to make primary alcohols. Now, we may have some synthetic reasons for not wanting to reduce all the way to a primary alcohol. We might want to stop at the aldehyde oxidation state. And so we're going to look at the use of two reagents and two methods of getting to aldehydes from carboxylic acid derivatives. And so let's look at these reagents first. These are milder reducing agents than lithium aluminum hydride. There's structural variants of these. Okay, and the first one is lithium tritert butoxy aluminum hydride. It's a little bit of a mouthful here. But basically what it is we're taking three of the hydrogens and we are replacing them with tert butoxy groups. All right, and so what that's going to look like, you kind of look at the structure a little more closely, is we've got three tert butoxy groups, and I'm going to even kind of show you a little more detail of what this tert butyl group looks like on this right one. Okay, so this is showing you all the atoms involved in the tert butoxy group right there, and we have three of them. So T-Bu is tert butyl. Okay, and so having these groups here in place of a hydrogen makes this a milder reducing agent. So this, and we typically would use this to convert an acid chloride to an aldehyde. All right. A second one that we could use is diisobutyl aluminum hydride. Okay. So IBU, two of those attached to aluminum, and we've got one hydrogen attached to that aluminum. So diisobutyl aluminum hydride. This is often abbreviated as Dibol. Okay, and what this is going to look like. Okay, there's our hydride equivalent, quote H minus, all right? And we have two isobutyl groups, okay? Butyl means 4. 1, 2, 3, 4. Iso means an isomer of, say, N-butyl, of the straight chain. Okay. If I had put this carbon here, we'd probably call it secondary butyl. But there we go, isobutyl. One thing that's to note, and that's probably part of the reason why these are weaker reducing agents, is we were using sterically bulky groups like isobutyl or tert butyl on here. Okay, maybe that helps us with solubility. I'm not so sure. I'm not really an expert on reducing agents, but anyway, so we would use this for reducing typically esters to aldehydes. That's one application of this. Okay, so let me give you a couple examples of this, of these reagents in action. Okay, so here's an acid chloride. All right, and we could use our mild reducing agent, lithium tritert butoxy aluminum hydride. Ugh, say that 20 times fast. Okay, and that's going to reduce us to the aldehyde. Okay. We could also take an ester. We'll use the ethyl ester here. And This one I believe is done in 2 steps. Diisobutyl aluminum hydride. Okay. Minus 78 degrees Celsius is a common. And then we have a water workup. And that will also take an ester to an aldehyde. Minus 78, the significance of that, that's the temperature of a mixture of dry ice or solid carbon dioxide and acetone. Okay? Now, if you have a different carboxylic acid derivative that you're trying to get to an aldehyde, we would typically try to convert those to the ester or the acid chloride, at least in the context of organic too. I'm sure there's a good chance there's other ways you could take an amide to an aldehyde in the literature. But this is what we're gonna do. So thanks for watching our video on reducing to aldehydes from carboxylic acid derivatives, and have a great day.